In this worksheet, we're going to take a quick look at derivatives of hyperbolic functions. We first notice the definitions of a hyperbolic sine and hyperbolic cosine here, and from those we get the definitions of all the other hyperbolic functions as well. Beneath that, we have the derivatives of the hyperbolic functions, and you'll notice the similarities to the derivatives of our trig functions. In this worksheet, we're going to focus primarily on the derivative of hyperbolic sine, the derivative of hyperbolic cosine, and the derivative of hyperbolic tangent. The problems below are going to focus on using these rules in conjunction with the power rule, the product rule, the quotient rule, the chain rule, etc. Example 1, find the derivative of each function. So we're immediately noticing with part A that we have a quotient. So when we take this derivative, we're going to do the quotient rule. So we have our bottom function times the derivative of hyperbolic sine 2x. So we need to take the derivative of this. We're going to use this rule, which will give us hyperbolic cosine of 2x, but then chain rule, we have to multiply by the derivative of the inner function. The derivative of 2x is 2. So there we have the bottom function times the derivative of the top minus the top function, which is hyperbolic sine of 2x, times the derivative of the bottom. The derivative of x squared is 2x, all over the square of the denominator. Now we'll notice that in the numerator we can factor out an x. We could also factor out a 2, but let's just factor out the x, so that way we can cancel in the denominator. So the first term, when we factor out the x, gives us a 2x hyperbolic cosine of 2x minus 2 hyperbolic sine of 2x. And in the bottom we have x to the fourth. Canceling, we get a result that looks like this. Let's go on to part B. Here we notice that we have hyperbolic tangent raised to the fourth power. So this can be rewritten this way. So now it's a matter of applying the chain rule. So when we take this derivative, we'll first take the derivative of the fourth power, leaving the inner function alone, raising it now to the third power. Then we multiply by the derivative of hyperbolic tangent, which is hyperbolic secant squared. And finally, we multiply by the derivative of the inner function, which is just 5. Part C, here we have a product of sine x and hyperbolic cosine of x squared. So we're going to need to use the product rule. So we're going to have the first function. We notice that the derivative of hyperbolic cosine is positive hyperbolic sine, and then we multiply by the derivative of the inner function. So we have our first function times the derivative of the second. Next we need the second function times the derivative of the first. The derivative of sine is simply cosine. There really isn't anything we can simplify here. Maybe just rewrite it with the 2x in front. Now, part D looks a little involved. The way it's written makes us think that we're going to need to use a quotient rule and a chain rule. And we could do it that way, but let's try something a little different. Let's first notice that we have hyperbolic sine of pi x, but we also have hyperbolic cosine of pi x. So looking at the top of the page where we have the definitions of hyperbolic sine and hyperbolic cosine, let's see what happens when we rewrite this function using those definitions. In other words, for hyperbolic sine of pi x, we could write e to the pi x minus e to the negative pi x over 2. And then for hyperbolic cosine, we could write e to the pi x plus e to the negative pi x over 2. Notice that both of these fractions have 2 in the denominator. So we could take the numerator of the blue one and add the numerator of the green one all over 2, and all of that is still being divided by e to the 2 pi x. Distributing the 3's, we get this. And then we notice that we get some cancellation. This term here will cancel with this term here. When we add the remaining terms, we have 6e to the pi x over 2 divided by e to the 2 pi x. That's going to simplify to 3e to the pi x over e to the 2 pi x. This will simplify even further to 3e to the negative pi x. This looks like it's going to be a much easier derivative than the original function that we started with. So now we can simply say that g prime of x is the derivative of this guy, which is going to be 3e to the negative pi x, but then we have to multiply by the derivative of the inner function, which will be a negative pi. Rewriting this so we don't have any negative exponents, we have negative 3 pi in the numerator and e to the positive pi x in the denominator. So in some cases, it's easier to rewrite our hyperbolic functions in terms of their original definitions, and then simplifying the function before taking a derivative. Example 2, find dy dx if hyperbolic cosine squared x plus x times hyperbolic sine of 2y is equal to 5. So here we're going to be doing implicit differentiation. We're going to take the derivative with respect to x of each side. So for this first term, we're going to use the chain rule. And with the next term, we're going to need to use the product rule. So we have the first function times the derivative of the second function. Chain rule gives us that 2 when taking the derivative of 2y, and of course we need our dy dx here. Then we're going to add to that the second function, which is our hyperbolic sine of 2y, times the derivative of the first function, which was x. That derivative is just 1. And on the right-hand side, we get 0. Now we just need to isolate dy dx. Go ahead and do the similar problems that follow.